Welcome to VLSI Drilling channel. Subscribe the channel for new videos. So today let us study about synchronous versus asynchronous reset. First of all, let us consider one example for synchronous reset module. Here we are defining some input ports and some output ports for the module. Significant input ports being clock and reset underscore n. Now always at the rate passage clock. So at the rising edge of the clock, every time we are checking if not of reset underscore n is active, if that condition bracket condition becomes high, then we are assigning data with 0 values. So whenever the reset is enabled, this is active low reset, so we are defining in this way. Whenever reset is active, then it will assign data with zeros. So in synchronous reset module, the input reset underscore n is synchronized with the clock signal using an edge triggered flip flop. The reset condition is checked on the rising edge of the clock, and if reset underscore n is low, the data is reset to 0. Else, we will update the data as per the input ports. If we are using active high reset, then the code will change like this. Always at the rate passage clock. If reset condition is high, then we are assigning output with zeros, else we are assigning output with input. Now let us see an example for asynchronous reset module. So here also we are defining input and output ports, and here the condition, always condition will change for asynchronous reset. Here always at the rate passage clock or negage reset underscore n. We are checking at rising edge of clock. Also we are checking, we have to check with respect to negage of reset underscore n. Negage of reset underscore n will mean that the reset is getting enabled. So as soon as the reset is getting enabled, we have to assign data with all zeros. So here one more condition we have added, if not of reset underscore n, that is the reset has got enabled, then we will assign the data with zeros. So in asynchronous reset module, the input reset underscore n is checked on rising edge of clock and also with negage of reset underscore n, that is when it will be active. Hence, when reset underscore n is low, that is it's active, the data is reset to 0 regardless of current clock state. This is asynchronous reset. In case the reset is active high, then our code changes like this. We will check always at the rate passage clock or passage reset because it is active high. So at the rising edge of the reset, we are checking our condition. Then we are checking if reset is enabled, then out will be assigned with 0, else output will be assigned with input. So what do we conclude from our earlier discussion? That for synchronous reset, it means reset is sampled with respect to the clock. That is when reset is enabled. It will not be effective till the next active clock edge. It will wait for the clock edge to become active. Reset is synchronized to the clock signal of the circuit. The reset signal will be recognized and acted upon at a specific edge of clock signal, usually rising or falling edge. It is commonly used in sequential logic circuits to ensure that reset operation occurs at a known and predictable time relative to the clock. What are the disadvantages of synchronous reset? That it requires presence of clock to reset the circuit, plus it is slow in nature. On the other hand, asynchronous reset means reset is sampled independent of clock. That is, when reset is enabled, it will be effective immediately and will not check or wait for clock edges. Asynchronous reset is not synchronized to the clock signal. It can occur at any time independent of the clock signal. It is often used in situations where immediate and independent reset operation is required, such as in critical error conditions. What are the advantages of asynchronous reset? Reset gets the highest priority. It is fast in nature and it doesn't require presence of clock to reset the circuit. So, this way we understood about synchronous and asynchronous reset. Thanks for watching the video. Don't forget to subscribe the channel. Bye-bye.